Hi there, Cougar Academy Algebra 2, and welcome to Lesson 1.1. Today we're going to be discussing what are the different classifications of numbers and what are the properties of algebra. So, a pretty basic lesson to get us started here into Algebra 2. Okay? The first thing we're going to focus on are number classifications. So we're basically going to be dealing with two types of numbers: rational numbers, okay, and irrational numbers. Rational numbers, okay, here's some examples of those. They are numbers that can be represented as fractions, okay? So rational numbers are fractional, fractional, you can think, okay? They also include things such as terminating decimals, and they also have a few other subcategories. So rational versus irrational, okay? Irrational, on the other hand, cannot be represented as a fraction, okay? So they cannot be fractions. And that just means that they are non-terminating decimals. Terminating decimals. Okay? Most likely, these types of numbers, if you're familiar, are like the number pi. It goes on and on forever. If you see non-perfect square roots, so like the square root of 3, the square root of 5. If you type the number into your calculator, so you should have your calculators handy, say you type in the square root of 6, okay, and you hit enter. Notice how none of these numbers are repeating. There's no repeating or anything like that. It's just random. Also, if you go to math, fraction, enter, it does not make a fraction for you, okay? So that means square root of 6 is also an example of an irrational number. Okay, on the other hand, if we go back and we type in the square root of 25, boom, we get a 5, okay? So rational numbers, back to these, they can be broken down further, okay? If it is simply a positive or a negative number, okay, then we refer to it as an integer. Okay, so it kind of works its way down. Integers, so these are not decimals. These are things like -5, -4, -3, -2, 0, 1, 2, 3, 4, so on. Okay? And one more breakdown are whole numbers. Okay? And simply those are positives. Okay? So positive numbers, 0 included, 0, 1, 2, 3, 4, and so on. Okay? Not decimals. Okay? Integers and whole numbers are not decimals. That is a weird way to spell decimals. Okay, so let's just classify these and then we're going to arrange them on a number line. All right, so we want to classify as the most specific type it is. -7, okay, so looking at our little definitions above, so it's rational, but it also falls in the integer category. Whole numbers cannot be positive, so this is an integer. Okay. Quattro. Quattro is 4, which is also a rational. It's an integer, and it goes into a whole number. Okay. Okay, so it's a whole number. Square root of 2. Square root of 2, just to check in your calculator, 1.4, so on. If you try the little fraction trick, doesn't work out. So it's going to be an irrational number. 13 over 10. Well, right off the bat, if it's a fraction, then it must be at least a rational number. Now, since it's a decimal in a sense, or a fraction, so 13 over 10 is really 1.3, and that will help us graph on a line in the future. 1.3, this is most specific, just a rational number. Pi, well, there's a little easy one for you. 3.14, and so forth. Now again, pi, 3.14159, and it goes on and on and on forever. It's an irrational number. And 7.5, all right, that can be represented as a decimal. So one thing students always ask, fractions and decimals, they're really interchangeable. So I know students are like, well, it's a decimal, it's not a fraction. Really, it's the same idea. 7.5, again, if you, in this case, go to fraction, it's 15 halves. So it is rational. Okay, on a number line, so it's also a good idea just to get an idea as to what all these are. I just made square root of 2 into 1.41 just to give us an idea. And I'm just going to make our own little number line here. Boop. It's always important, let's plot 0 at least. And we'll get some ideas here. So 1, 2, 3, 4, 5, 6, 7. There's -7. Okay. 1.3. 1, 2, 3, 4, 5. So 1.3. And you don't have to be super exact if you're making your own number line. It's just to kind of give you an idea and to give you a sense of how big these numbers are. 123.14. So pi would be in about there. Whole number is just 4. 1, 2, 3, 4. Okay. Irrational, square root of 2, 1.41. So a little bit more than this here. So square root of 2. And again, don't worry about if you're a little bit off. And 1, 2, 3, 4, 5, 6, 7.5. Did you do that right? 1, 2, 3, 4, 5, 6, 7.5. And did I miss any? I think we're okay. 1, 2, 3, 4, 5, 6. Alrighty. So those are types of numbers. The next step, or our next topic, are the properties of algebra. So we have a few properties here. Really, you've done these, you just haven't put a name to them. So the properties of algebra, they can get a little confusing, but we're going to practice these here. First up is the commutative property. So we're going to look at some examples of this here. Commutative property states if you have a few numbers here, so we're going to use letters, so A plus B is equal to B plus A. Okay, basically it says we can switch these numbers around and call it a day there. Same idea, so if you think of it as, hey, well, 5 plus 1 is equal to 1 plus 5. Okay, it also works for multiplication. So A times B is equal to B times A. And that's about it there. Number-wise, 5 times 3 is equal to 3 times 5. Okay, so notice that the numbers are commuting. They're switching spots. Okay, so I'm going to highlight them to emphasize that the numbers are moving spaces. Okay, the associative property typically involves associating different numbers in parentheses. Now, we are going to combine some of these ideas, but what this one says is that, well, if I have A plus B, and I do that first, and I add a C in there, it's the same thing as if I do A plus B plus C. Okay, so I'm just taking the B plus C instead of the A plus B first. You get the same result. Don't believe me? Well, if you try 5 plus 1 plus 3, okay, you get 9. If you also do 5 plus 1 plus 3 first, you still get 9. This again works for multiplication. So AB times C is equal to A times B times C. So notice here the parentheses are around different numbers. That is what is changing, okay? Because it can get confusing when we combine some of these properties. Inverse and identity properties are next. The inverse property, okay? Inverse property for addition, okay? So for addition, looks like this here. If we have A and we add its opposite, well, we get 0. So we know that 5 plus negative 5 is equal to 0. The inverse for multiplication, we refer to the reciprocal. So in this case, A times 1 over A is equal to 1. And just an example, 5 times 1 over 5 is equal to 1. Okay, we refer to 0 as the additive inverse and 1 as the multiplicative inverse. So we're dealing with the reciprocals for multiplication. The identity property, on the other hand, whatever you start with, you end with. So A plus 0 is equal to A, or 3 plus 0 is equal to 3. The identity, it's like looking in a mirror, okay? You start with it, and you look back, you get the same idea. For the multiplication, the identity is 1. So A times 1 equals A, or 3 times 1 equals 3. Okay? 0 and 1 are the additive and multiplicative identities. And the last properties are the distributive properties, okay? And you might see these in either way. So the distributive property starts out with A, and then say we have B plus C is equal to, if we distribute, AB plus AC. Thinking of it in terms of numbers, 5 times 1 plus, say, R is equal to 5 plus 5R. 5 times 1, 5 times R. Okay? Also, this isn't a formal property, but it's important to notice the distributive property in reverse. Okay? So say we start out with 12, and it's plus, let's say, 3R. Well, you can also undistribute the 3, and if we take that out of the 12, that leaves us with 4, and that leaves us with plus R. So it's the same idea, just backwards. Okay, you don't need to specify it's in reverse. If you do, that's fine, if you're just getting used to it. So those are the properties in a nutshell. Let's just go through some practice of these, because they can get a little confusing. And really, once you get the hang of it, once you understand what you're looking for, it's not too bad. So have those handy. Determine what property of algebra is represented in the expression. So 9 plus 4 is equal to 4 plus 9. The 9 is what's changing. Directions, the numbers are swapping. This is commutative. Okay, 16, 7 plus 3 plus 2. Here, 7 plus 3 plus 2. Now this one, okay, notice we are swapping where the parentheses are. Here we're adding the 3 plus 2 first. Here we're adding the 7 plus 3. So this is the associative. Okay, 10 times 1 equals 10. What do you guys think? Identity. Yes, we are getting the same number. Identity. 10 plus 0 equals 10. That's also the identity. This one's for addition, and the other one is for multiplication. So it looks similar, only we are dealing with multiplication in 17 and addition in 18. 19. So these are reciprocals. 1/5 and 5 are reciprocals of one another, equals 1. This is the inverse. And 5/4 times 1 equals 5/4. Now, just because you see fractions, don't let it scare you. Notice we're starting with 5/4. We look into a mirror, and we end with 5/4. So this, too, is the identity. Okay, 5/3, 3/5 equals 1. So on the right-hand side, we don't have 5/3. These numbers are reciprocals, so this is the inverse property. Inverse, because we have reciprocals. 12 plus negative 12 equals 0. If you said inverse, absolutely. Inverse for addition are the opposites. And 23, 24. Well, let's see. 5 times 3 is 15, and 2 is 10. This must be the distributive. And 24, 12 plus 9. Notice 3 times 4 is 12. 3 times 3 is 9. This is also the distributive. Distributive. And lastly, a plus b plus c. Okay, now here are the little curveballs. Notice the parentheses are around the same bunch of numbers, the b's and the c's. It's the numbers themselves that are switching. Okay, so this is a little curveball thrown at you. This is the commutative property. Just because you see parentheses doesn't mean it's distributive or associative. It's the numbers themselves that are switching. That's a common curveball they throw at you. A plus b equals c plus b. Here, I am undistributing a b. Okay, so it's the distributive. So just some more advanced examples there, 25, 26. So that's the notes, the properties, the types of numbers. All right, please get to practicing those. Submit a copy of your notes and everything. And great job, guys. Good luck.